Welcome to Mind Map MCQ. In this video, we will explore into the depths of atmosphere. Prepare, practice, prevail. Without wasting much time, let us get started. Question 1. Arrange the atmospheric layers in order starting from the layer nearest to Earth. 1. Mesosphere, 2. Exosphere, 3. Troposphere, 4. Thermosphere, and 5. Stratosphere. The options are A. 24513, B 42351, C 35142, or D 13425. The correct option is C 35142. Troposphere, which is 0 to 10 kilometers above Earth's surface, is followed by stratosphere 10 to 50 kilometers above Earth's surface. Mesosphere 50 to 85 kilometers above Earth's surface. Thermosphere is 85 to 600 kilometers above Earth's surface. The exosphere is 600 kilometers and beyond, gradually merging into space. 2. Which layer of the atmosphere contains the ozone layer? The options are A. Troposphere, B. Stratosphere, C. Mesosphere, D. Thermosphere. The correct option is B. Stratosphere. The ozone layer is located in the stratosphere, which is the second layer of Earth's atmosphere, situated above the troposphere and below the mesosphere. The stratosphere extends from about 10 to 50 kilometers above Earth's surface. The ozone layer within the stratosphere plays a crucial role in absorbing the majority of sun's harmful ultraviolet radiation, thereby protecting living organisms on Earth from potential damage caused by UV exposure. 3. In which layer of the atmosphere do meteors burn up on entering Earth's atmosphere? The options are A. Troposphere, B. Stratosphere, C. Thermosphere, D. Mesosphere. The correct option is D. Mesosphere. Meteors burn up on entering the Earth's atmosphere in the mesosphere, which is the third layer located above stratosphere and below thermosphere. The mesosphere extends from about 50 to 85 kilometers above Earth's surface. In this layer, temperatures decrease with altitude and the thin air provides enough friction to cause meteors to heat up and disintegrate, creating the bright streaks commonly known as shooting stars. 4. Which layer of the atmosphere is characterized by a decrease in temperature with increasing altitude? The options are A. Troposphere, B. Stratosphere, C. Mesosphere, D. Thermosphere. The correct option is A. Troposphere. The troposphere is a layer of the atmosphere characterized by a decrease in temperature with increasing altitude. This layer extends from the Earth's surface to about 8 to 15 kilometers high. The troposphere contains most of the atmosphere's mass and is where weather occurs. As you ascend in the troposphere, the temperature drops due to the decreasing air pressure and density. 5. What is the primary source of energy driving Earth's atmospheric processes? The options are A. Earth's internal heat, B. Atmospheric pressure differentials, C. Solar radiation, D. Ocean currents. The correct option is C. Solar radiation. The primary source of energy driving Earth's atmospheric processes is the sun. Solar radiation hits the Earth's surface, causing air to warm, rise, and create atmospheric circulation patterns. This energy drives weather systems, ocean currents, and climate patterns. It influences the water cycle through evaporation and precipitation and affects wind patterns by creating pressure differences. The distribution and intensity of solar energy also determines seasonal changes and temperature variations across different regions of the planet. 6. What causes the phenomenon known as the northern and southern lights, aurora borealis and aurora australis? The options are A. Lightning in the stratosphere, B. Solar wind interacting with the ionosphere, C. Air glow in the mesosphere, D. Satellite emissions. The correct option is B. Solar wind interacting with the ionosphere. The northern and the southern lights, known as aurora borealis and aurora australis, are caused by the interaction of charged particles from the solar wind with Earth's magnetosphere. When these particles collide with gases in the upper atmosphere, primarily in the thermosphere, they excite the gas molecules, causing them to emit light. The resulting colorful displays are most commonly seen near the polar regions, where the magnetic field lines converge and guide the charged particles towards the poles. 7. Which layer of the atmosphere is characterized by the highest temperatures due to absorption of solar radiation? The options are A. Thermosphere, B. Troposphere, C. Stratosphere, D. Mesosphere. The correct option is A. Thermosphere. The thermosphere is characterized by the highest temperatures due to the absorption of solar radiation. Located above mesosphere and extending from about 85 to 600 kilometers from the Earth's surface, the thermosphere experiences significant heating as it absorbs high energy ultraviolet and X-ray radiation from the sun. Despite the high temperatures, the air density is extremely low, so the total heat content is low and it would not feel hot to a human in this layer. 8. What is the primary function of the ozone layer in the atmosphere? The options are A. Regulating global temperatures, B. Facilitating cloud formation, C. Generating atmospheric electricity, D. Absorbing ultraviolet radiation. The correct option is D. Absorbing ultraviolet radiation. The primary function of ozone layer in the atmosphere is to absorb and filter out the majority of the sun's harmful ultraviolet radiation. Located in the stratosphere, this layer contains a high concentration of ozone molecules that effectively block UVB and UVC rays, which can cause skin cancer, cataracts and other health issues, as well as harm to ecosystems and wildlife. By protecting living organisms from excessive UV exposure, the ozone layer plays a crucial role in maintaining life on Earth. 9. What is the boundary between the tropopause and stratosphere called? The options are A. Tropopause, B. Stratopause, C. Mesopause, D. Thermopause. The correct option is A. Tropopause. The boundary between troposphere and the stratosphere is called the tropopause. It is a relatively thin layer where the temperature inversion occurs, marking the transition from the troposphere, where temperatures decrease with altitude, to stratosphere, where temperatures start to increase with altitude. The tropopause acts as a barrier to the atmospheric mixing, keeping the weather phenomena mostly confined to the troposphere. Its altitude varies with latitude and season, generally higher at the equator and lower at the poles. 10. What is the primary function of the ionosphere in terms of communication? The options are A. Absorbing ultraviolet radiation, B. Protecting from meteor impacts, C. Reflecting and refracting radio waves, D. Regulating atmospheric pressure. The correct option is C. Reflecting and refracting radio waves. The primary function of the ionosphere in terms of communication is to reflect and refract radio waves, enabling long distance radio transmissions. The ionized particles in this atmospheric layer allow radio signals to bounce back to Earth's surface rather than traveling into space. This reflection and refraction facilitate reliable radio communication over the vast distances, including for AM radio broadcast, shortwave radio and some navigation systems, by allowing signals to propagate beyond the horizon and around the globe. 11. During which time of day is the ionosphere most ionized and therefore most effective for radio wave propagation? The options are A. Early morning, B. Night, C. Evening, D. Noon. The correct option is D. Noon. The ionosphere is most ionized and therefore most effective for radio wave propagation during the daytime, particularly around midday. This is because the sun's ultraviolet radiation is at its peak, causing maximum ionization of the atmospheric particles. As a result, the ionospheric layers become highly ionized, enhancing their ability to reflect and refract radio waves over long distances. Conversely, ionization levels decrease at night, reducing the ionosphere's effectiveness for radio wave propagation. 12. Which layer of the atmosphere contains the ozone hole, which was primarily caused by human made chemicals called chlorofluorocarbons or CFCs? A. Troposphere, B. Stratosphere, C. Mesosphere, D. Thermosphere. The correct option is B. Stratosphere. The ozone hole is located in the stratosphere, which is the second layer of Earth's atmosphere. This depletion of ozone is primarily caused by human-made chemicals called chlorofluorocarbons or CFCs. When CFCs reach stratosphere, they release chlorine atoms through photodissociation, which then breaks down ozone molecules. This process has led to significant thinning of the ozone layer, particularly over the polar regions, resulting in the phenomenon called the ozone hole. 13. What is the primary composition of the exosphere? The options are A. Oxygen and nitrogen, B. Hydrogen and helium, C. Carbon dioxide and methane, D. Ozone and water vapor. The correct option is B. Hydrogen and helium. The exosphere is primarily composed of extremely low density particles including hydrogen and helium. These particles are so sparse that they rarely collide with one another, and some even escape into space. The exosphere is the outermost layer of the Earth's atmosphere, extending from about 600 kilometers above Earth's surface to the point where it merges with the solar wind in the outer space. This layer has very few molecules and it gradually transitions into the vacuum of space. 14. How does the temperature in the exosphere change with altitude? A. Fluctuates unpredictably with altitude, B. Decreases with altitude, C. Remains constant with altitude, D. Increases with altitude. The correct option is A. Fluctuates unpredictably with altitude. Temperature is generally not a function of altitude in the exosphere, unlike the layers below it. The temperatures in the exosphere can vary significantly due to the sparse nature of gases and their interaction with incoming solar radiation. Near Earth exospheric temperatures can range from hundreds of degrees Celsius during daytime to near absolute zero at night, depending on solar activity and the density of particles at different altitudes. 15. What is the average atmospheric pressure at sea level in standard atmospheric pressure units? The options are A. 0.5 atmosphere, B. 2 atmosphere, C. 1 atmosphere, D. 0.1 atmosphere. The correct option is C. 1 atmosphere. The average atmospheric pressure at sea level under the standard atmospheric conditions is approximately 1013.25 millibar. This value is equivalent to 1 atmosphere. Atmospheric pressure decreases with altitude as the weight of the overlying air decreases. Standard atmospheric pressure serves as a reference point for various atmospheric and meteorological measurements influencing weather patterns, air density, and the behavior of gases within the Earth's atmosphere. 16. What is the layer of the atmosphere where the weather phenomena such as clouds, rain, and storms occur? The options are A. Stratosphere, D. Mesosphere, C. Thermosphere, D. Troposphere. The correct option is D. Troposphere. The layer of the atmosphere where weather phenomena such as clouds, rain, and storms occur is the troposphere. This layer is closest to the Earth's surface, extending from the surface up to an average altitude of about 8 to 15 kilometers. In the troposphere, temperature generally decreases with altitude, providing conditions suitable for the formation of clouds and precipitation through the processes like condensation and convection. It is where most of the Earth's weather occurs, driven by interactions between air masses and varying solar heating. 17. Which gas is primarily responsible for maintaining the Earth's surface temperature within a habitable range through the greenhouse effect? The options are A. Carbon dioxide, B. Oxygen, C. Nitrogen, D. Methane. The correct option is A. Carbon dioxide. The gas primarily responsible for maintaining Earth's surface temperature within a habitable range through the greenhouse effect is carbon dioxide. Along with other greenhouse gases like water vapor and methane, carbon dioxide traps outgoing infrared radiation from Earth's surface, preventing it from escaping directly into space. This process enhances the overall temperature of the atmosphere and surface, making Earth warm enough to support life as we know it. However, human activities have significantly increased carbon dioxide levels, leading to concerns about enhanced greenhouse warming and climate change. 18. What does albedo measure? A. Temperature of an object. B. Reflectivity of an object. C. Transparency of an object. D. Absorption of radiation by an object. The correct option is B. Reflectivity of an object. Albedo measures the reflectivity of a surface or object, quantifying the fraction of incoming solar radiation that is reflected back into space. It is expressed as a percentage or fraction between 0 and 1, where higher values indicate greater reflectivity. Albedo affects Earth's energy balance and climate by influencing how much solar energy is absorbed versus reflected. Surfaces with high albedo, like snow and ice, reflect more sunlight, while darker surfaces like forests and oceans absorb more solar radiation and have lower albedo. 19. How does albedo affect climate? The options are A. High albedo warms the earth. B. High albedo stabilizes weather patterns. C. High albedo cools the earth. D. Low albedo increases precipitation. The correct option is C. High albedo cools the earth. High albedo surfaces reflect a greater portion of incoming solar radiation back into space, reducing the amount of solar energy absorbed by Earth's surface. This reflection results in lower surface temperatures compared to surfaces with lower albedo, which absorb more solar radiation and therefore experience higher temperatures. Examples of high albedo surfaces include ice caps, glaciers, and clouds, which contribute to cooling effects of Earth's climate. 20. Which of the following factors does not influence the albedo of a surface? A. Color of the surface. B. Texture of the surface. C. Angle of incidence of sunlight. D. Thickness of the atmosphere. The correct option is D. Thickness of the atmosphere. Albedo is primarily influenced by factors such as the color of the surface, its texture, and angle of incidence of sunlight. These factors determine how much solar radiation is reflected versus absorbed by the surface. The thickness of the atmosphere affects other aspects of climate and radiation absorption, but not directly the albedo of the surface itself. 21. Which type of radiation is primarily responsible for heating the Earth's surface? The options are A. Ultraviolet radiation. B. X-ray radiation. C. Gamma radiation. D. Infrared radiation. The correct option is D. Infrared radiation. The type of radiation primarily responsible for heating the Earth's surface is infrared radiation. This radiation is emitted by Earth's surface and is absorbed by greenhouse gases such as water vapor, carbon dioxide, and methane in the atmosphere. These gases trap infrared radiation, preventing it from escaping directly into space and effectively warming the lower atmosphere on Earth's surface. This process, known as greenhouse effect, is essential for maintaining Earth's average surface temperature within a habitable range for life. 22. Which type of UV radiation is most harmful to human health and can cause skin cancer? The options are A. UVA, B. UVC, C. UVB, D. UVD. The correct option is UVB. The type of UV radiation most harmful to human health and capable of causing skin cancer is UVB radiation. UVB has a shorter wavelength than UVA radiation and is more energetic. It penetrates the outer layer of the skin more deeply, damaging DNA in skin cells and increasing the risk of skin cancer. Prolonged exposure to UVB radiation from sunlight is a significant risk factor for skin cancers. 23. What role does water vapor play in the absorption of infrared radiation in the atmosphere? The options are A. Reflects IR radiation back into space. B. Enhances IR absorption. C. Decreases IR absorption. D. Generates IR radiation. The correct option is B. Enhances IR absorption. Water vapor in the atmosphere plays a crucial role in the absorption of infrared radiation. It is a potent greenhouse gas that absorbs specific wavelengths of IR radiation emitted by the Earth's surface. This absorption traps heat within the lower atmosphere, contributing to the greenhouse effect and warming the Earth's surface. Water vapor's concentration in the atmosphere varies with temperature and plays a dynamic role in regulating the planet's energy balance and climate system through its interaction with IR radiation. 24. Which of the following gases is not considered a greenhouse gas? Options are A. Oxygen, B. Carbon dioxide, C. Methane, D. Water vapor. The correct option is A. Oxygen. Oxygen is not considered a greenhouse gas because it does not significantly absorb or emit infrared radiation in the Earth's atmosphere. Greenhouse gases like carbon dioxide, methane, and water vapor are able to absorb and re-emit infrared radiation, thereby trapping heat and contributing to the greenhouse effect. Oxygen molecules in contrast are diatomic and do not exhibit the same infrared absorption characteristics necessary to contribute to warming the atmosphere in this way. 25. Which greenhouse gas is primarily released through agricultural activities such as rice cultivation and livestock farming? The options are A. Carbon dioxide, B. Methane, C. Nitrous oxide, D. Ozone. The correct option is methane. Methane is a potent greenhouse gas produced by livestock through enteric fermentation, a digestive process in animals like cattle, sheep, and goats. During digestion, microbes in the animal stomachs produce methane as a byproduct, which is then released through belching. Methane has a much higher heat trapping ability per molecule compared to carbon dioxide, contributing significantly to global warming when released into the atmosphere. 26. Which greenhouse gas has a global warming potential or GWP much higher than carbon dioxide over a 20-year period? The options are A. Methane, B. Nitrous oxide, C. Water vapor, D. Ozone. The correct option is A. Methane. Despite having a shorter atmospheric lifetime than carbon dioxide, methane is about 84 times more potent in trapping heat over a 20-year time frame, mainly due to its strong infrared absorbing properties. This heightened GWP underscores the methane's significant impact on near-term climate change, particularly from sources like agriculture, landfills, and natural gas production and its distribution. 27. Which layer of the atmosphere experiences enhanced warming due to the greenhouse effect? The options are A. Stratosphere, B. Mesosphere, C. Troposphere, D. Thermosphere. The correct option is C. Troposphere. The troposphere, the lowest layer of the atmosphere, experiences enhanced warming due to the greenhouse effect. Greenhouse gases such as carbon dioxide, methane, and water vapor absorb and re-emit infrared radiation emitted by the Earth's surface. This process traps heat within the troposphere, leading to an overall warming effect. The concentration of greenhouse gases has increased due to human activities, intensifying this warming trend and influencing global climate patterns and weather phenomena within this critical atmospheric layer. 28. Which human activity is not a major source of greenhouse gas emissions? The options are A. Transportation, B. Agriculture, C. Deforestation, D. Nuclear power generation. The correct option is D. Nuclear power generation. Nuclear power generation does not emit greenhouse gases directly during electricity production. It relies on nuclear fission to generate heat, which then produces electricity through steam turbines. Unlike transportation, agriculture, and deforestation, which involve processes that release significant amounts of greenhouse gases such as carbon dioxide and methane, nuclear power generation is considered a low carbon or a zero carbon energy source in terms of direct emissions. 29. Which region of the earth experiences the strongest greenhouse effect? The options are A. Polar regions, B. Equatorial regions, C. Desert regions, D. Mountainous regions. The correct option is A. Polar regions. The polar regions experience a particularly strong greenhouse effect due to several factors. Firstly, surfaces covered with ice and snow have high albedo, reflecting a large portion of incoming solar radiation. However, as temperatures rise and ice melts, darker surfaces are exposed, which absorb more heat and aggravate warming. Additionally, feedback mechanisms such as the release of methane from melting permafrost further intensify the greenhouse effect. These factors contribute to accelerated warming in polar regions, leading to rapid environmental changes. 30. Which gas released through soil cultivation and synthetic fertilizers contributes to both ozone depletion and the greenhouse effect? The options are A. Carbon dioxide, B. Nitrous oxide, C. Methane, D. Chlorofluorocarbons. The correct option is B. Nitrous oxide. Nitrous oxide released through soil cultivation and the use of synthetic fertilizers contributes to both ozone depletion and the greenhouse effect. It is a potent greenhouse gas with a high global warming potential, about 298 times that of carbon dioxide over a 100-year period. In the stratosphere, nitrous oxide reacts with ozone, contributing to ozone depletion. At lower altitudes, it traps heat in the atmosphere, contributing to global warming and climate change, making it a significant environmental concern. 31. What is Kármán line? The options are A. The line above which commercial flights do not go, B. Line that separates the stratosphere and troposphere, C. Outer layer of thermosphere, D. A boundary that marks the edge of space. The correct option is D. Boundary that marks the edge of space. The Kármán line is an altitude of approximately 100 kilometers above Earth's sea level, widely recognized as the boundary between Earth's atmosphere and outer space. It marks the point where atmospheric density is so low that aerodynamic flight is no longer possible and spacecraft transition from atmospheric to space conditions. This line is a standard reference to aerospace and space travel, helping to define when a vehicle is officially in space. 32. What is exobase? The options are A. Boundary between mesosphere and stratosphere, B. Layer where most weather phenomena occur, C. Transition zone where atmospheric particles can escape into space, D. Point where the thermosphere meets the troposphere. The correct option is C. Transition zone where atmospheric particles can escape into space. The exobase is the boundary layer between thermosphere and exosphere, located approximately 500 to 1000 kilometers above Earth's surface. At this altitude, atmospheric particles are so sparse that they rarely collide, allowing them to escape into space. The exobase represents the transition point where the atmosphere becomes extremely thin and gradually merges into the vacuum of space, marking the upper limit of Earth's atmospheric influence.